Another application is the Brownian motion, and if you remember, Brownian motion occurs for micron-sized macroscopic particles that are suspended in a fluid. When we investigate their motion under the microscope, we see that they have random fluctuations, and that's called Brownian motion. And so this is so basically what we see in this motion is that when we increase the mass of the particles, the macroscopic particles, the fluctuations that we observe will have less amplitude. So we find that the fluctuations become harder to observe as the particles become more massive. So we would like to explain this phenomenon using the equipartition theorem. So we're considering a micron sized macroscopic particle which has mass m that is suspended in a fluid at an absolute temperature T. So this is like a small system in contact with a heat reservoir, which is the rest of the particles. So we can write the energy, its energy, as in the case of any gas energy, we can have epsilon, the energy per particle, 1/2m px squared plus py squared plus pz squared. This is the translational motion of the center of mass, and then the energy that's coming from vibrations and rotations. So this part is once again center of mass translations, and that allows us to write 1/2m Vx square bar to be equal to 1/2 kT. So once again we have Vx square bar is kT over m, and the standard deviation or the amplitude of the fluctuations in Vx will be square root kT over m, because we have Vx bar is equal to 0, Vx minus Vx bar squared average is just Vx square average. So this is basically telling us a very important physical result, that is the dependence on the mass. So we have the fluctuation amplitude dependent on the mass with a factor proportional to 1/square root m. So the conclusion is that the particle will fluctuate. So we will see fluctuations of the particle under the microscope. However, as the particle mass increases, the fluctuations will be harder to observe. The fluctuations are harder to observe because the fluctuation amplitude in velocity components will be decreasing with 1/square root m as the mass of the particle increases. So basically, equipartition theorem tells us a physical phenomenon that we observe when we have a suspended micron-sized particle in a fluid at absolute temperature T. So it's in thermal contact with the rest of the fluid and particles in the fluid. Its energy is due to center of mass translations and vibrations and rotations with respect to center of mass if it's a molecule. let's say, and we're observing the fluctuations of the center of mass under the microscope, and therefore we're interested in the amplitude of these fluctuations, and we see that for the x component of the velocity, for example, this fluctuation amplitude scales as 1 over square root m. That comes from the equipartition theorem. The mean value of 1 over 2 m vx squared is 1 over 2 kt. And since the mean Vx value will be 0, this is from symmetry, because it's due to random collisions with the other particles in the fluid. We will have the Vx minus Vx bar squared average value, that the variance will be Vx squared bar. So the standard deviation is square root of that, square root kt over m. So as a result, as the mass of the particle increases, the fluctuations become harder to